In this video, we're going to use geometry and algebra to find the volume of a soda cup. The materials that I'm going to use is a large glass and a ruler. I'm going to use the ruler to measure the diameter of the bottom of the cup, just 6.5 centimeters. The top of the cup, which is 10 centimeters, and the height of the cup, which it actually works best to hold it upside down and measure the height, but it's 18 centimeters. Because the cup looks very much like our truncated cone. So what I'm going to do is I think of this as, this is going to be where my y-axis is, and right in the middle is going to be where the x-axis is, and it's a line that's rotated around the y-axis. So in this situation, I wasn't given the equations. I'm just given the measurements, or I found the measurements. And what I'm going to do is I'm going to sketch it on an axis so I can get organized and I can see what information I have and how I can find the volume. So I'm going to place the diameter of the bottom of the cup is going to be here, and I'm going to have it open up over here. So the radius is going to be 3.25. So I'm going to just say that this is 3.25. And then over here I have the diameter of the top of the cup was 10. So this radius is going to be 5. And this is 3.25, and my height here was 18 centimeters. Now what I need to do is I need to come up with the equation that goes here. So to do that, I need to know the coordinates of these 2 points, and I can use algebra. So the x value here is 18, and the y value is 5. And here the x value is 0, and the y value is 3.25. And that's going to give me, I can draw in the line, but I'm going to need the equation, and I'm going to bring it over here to find out where it crosses the x-axis. And then I'm going to revolve it here to come up with the volume of my big cone, and then I'll take off the top of it to come up with the volume of my cup. Okay, so I have this information, but I need to know this point. So to do that, I need to know the equation of this line. So I have 2 points, so I can find the slope, because I know that my slope is y2 minus y1 over x2 minus x1. So I'm going to say that it is 5 minus 3.25 for 18 minus 0, and this gives me 1.75 over 18. That's my slope. And I'm just going to divide it out on the calculator to get an approximation. And that gives me approximately, the slope is approximately 0.097. So that's the slope of my line. Now if I use the point slope form of an equation, which is y minus y1 equals m times x minus x1, and now the choice of my 2 points, I'm going to use this point right here, so I have y minus 3.25 equals m times, oops, I didn't write in the value for m, which is 0.097 times x minus 0. So I have, I'll rewrite it, y minus 3.25 equals 0.097x. Bring the minus 3.25 to the other side, and I get y equals 0.097x plus 3.25. So that's my equation. So I need my equation in order to find the top. If I can find this point, then this point right here, it'll give me the height of the top of the cone. And I know at this point right here, the y value is 0. So when y equals 0, my equation, set my equation equal to 0 plus 3.25. Then I'll bring the negative 3.25 to the other side, and then divide by 0.097, divide by 0.097, and x equals what, negative 33.5. Okay, so this point right here is negative 33.5 and 0. So that gives me, it tells me that this height right here, this length, this height is, well, it's going to have to be the absolute value. It's 33.5 centimeters. So using that, now I can go ahead and calculate the volume. So I have the volume equals 1/3 pi the large R squared large H minus 1/3 pi little r little h, the top. So it's the volume of the whole big cone minus the volume of the top, and that'll give me the volume of the green glass. So the volume is, and I'll take out the 1/3 pi, and it gives me r squared h minus r squared h. So what I have right now is 1/3 pi, and I need the radius of the big cone, which is right here, so that's 5. And I need the height of the big cone. So this is 18, and this length is 33.5. So I'm going to add the height of my big cone is the absolute value of this amount. So that is, the height is 33.5 plus 18, which is 51.5 minus the radius of the little cone, which is right here, which is 3.25 squared times the height. We take the absolute value, which is 33.5. And then we'll multiply this out. The volume is 1/3 pi times. And when we multiply this all out, we get, on the inside here, we're going to get 933.7. Take a third, and so our volume is 311 pi. And multiplying pi as, let's say, 3.14, your volume is 977 centimeters cubed, which is the same as 977 milliliters. That's our volume. But if we want to see how much it actually holds, then we can just do an approximate conversion. And on this soda can, it tells me that 355 milliliters equals 12 ounces. So I can divide it by 355, multiply it times 12. I can do my 977 times milliliters. Times, put the milliliters on the bottom, 12 ounces on the top. And when I multiply it out, it comes out to be 33 ounces. So I calculated that it would hold 33 ounces, which is really close because it's a 32-ounce container. So we used our geometry and we used algebra to calculate the volume of a cup. As long as the sides are straight, it can be like your the soda cups, most of and lots of the fast food places, and there's just lots of cups that you can calculate the volume using geometry and algebra, or you can also use the calculus. But here there's a few steps that we followed, but it is doable at the high school before students get into calculus. And that concludes this video. Thank you.